Good morning, good afternoon, and good evening, depending upon where we find you in the TOC world today. For those of you who I have not met, I'm Marcia Hutchinson, the General Manager for the TOC ICO, and it's my pleasure to welcome you here today. Our presenter today is Sanjeev Gupta, and he will be presenting parts 2 and 3 of his Masterclass series on how to execute projects faster and more efficiently. So we will be going a little bit longer than our normal sessions today. Sanjeev has founded 2 companies to provide TOC solutions, Throughput Technologies and Realization Technologies. And Throughput was named a top 5 vendor of manufacturing planning and scheduling software by AMR Research in 1997. And Realization's customers have achieved more than $6 billion in bottom line benefits using the knowledge he will share in this masterclass. Sanjeev has a BS in Mechanical Engineering from the Indian Institute of Technology in Delhi and an MS in Management and Public Policy from Carnegie Mellon University. And just a point of note here, the Project Strategy and Tactics Tree, authored by Dr. Goldratt, is based on Realization's implementation process, as proven and presented by its customers and its Project Flow conferences. So sit back, relax, and I'm turning it over to Sanjeev now, and here you go, Sanjeev. Thank you.
Thank you, Marcia, and hello, everyone. We will take off from where we left last time. And just to recap, what we did last time was I tried to make a distinction between critical chain project management and focus and finish, and also try to illustrate why the results from all the CCPM implementations actually come from focus and finish, not from CCPM itself. CCPM is important in the sense that it solves the problem of static project plans very elegantly by keeping project plans alive in execution. But the main takeaway from me as I look back at the last 20 years of implementing critical chain in more than 350 organizations and 75 large infrastructure projects is that the results come from focus and finish. We can implement critical chain project management, the techniques of critical chain project management, and not get any results or improvements in project cycle times or improvements in throughput if we do not do focus and finish. On the other hand, we can implement focus and finish without critical chain project management, especially in small projects and small project teams. And that is where the results come from. Okay, so one of the questions that was asked after the webinar last time, and I want to take that question on, is when we say focus and finish, how much should we focus and finish? How many resources should we put on per project? Does it mean that we should leave resources idle as we do more and more focus and finish? So I want to answer that question first before moving into the details of planning and some of the execution practices. And so one point to clarify is that focus and finish is not just in terms of number of projects that you are working on at any time. Focus and finish also applies within projects. So, and hopefully that is what I will be able to demonstrate through my project planning tutorial today. But conceptually, this is what we are saying, right? That if you increase the resource density, which means number of resources per unit of work, then your cycle times go down, but they don't go down linearly. At some point, there's going to be a plateau. But also what it means is if you increase the resource density, then your number of work streams that you have in execution is also reducing. So when you reduce the cycle time, in some sense, you are able to do more projects in the same amount of time. But when you reduce the number of work streams, then you are doing fewer projects in the same amount of time. And the combination of those is what you are looking to improve. Now, theoretically, this is the graph But in reality, what we find is that most organizations are on the left side here. So they can very easily, so most of the organizations are not operating on the right side of the curve, they are operating on the left side of the curve. And the acid tester, the litmus test is very simple, which is if you go into organizations, what is the situation you will find yourself in? Will you find that you have more work in front of people or you have more people than work? So are your people mostly sitting idle? Then you are probably on the right side of the curve. If your people are not sitting idle and if you have more work in front of people than what they can handle at any given time, then you are operating on the left side of the curve. So from wherever you are today, you can easily reduce in our experience. I mean, this is your work in process at the task level, at the phase level, at the work stream level, or at the project level, easily by a factor of 2, if not more, and still remain on the left side of the curve rather than jumping over, moving over to the right side of the curve. Now, I will just take a very simple example of this focus and finish and show you how this focus and finish both reduces the cycle time and increases throughput. So this is an example from one of our customers. They are an aircraft system supplier and they provide engineering for the entire fuselage of 737 aircraft. And the situation they were facing was that you can think of the fuselage as being divided into 6 sections. The situation they were facing was that all 6 sections of the fuselage were being developed simultaneously for whatever reason. And they were projecting the engineering lead time of 9 months. Their past experience, of course, always was that whatever they projected or planned was never achieved. And there are 60 people who were working on these 6 sections. On top of these 60 people, there were 20 management and support resources that were supporting all the different sections. And the challenge they had was they wanted to hit this lead time of 9 months, but with lower cost. So how did we go about achieving it? So what we did was we, instead of working on all these 6 sections in parallel, when we did the analysis, what we found was that if you double the number of engineers per section, you could actually reduce the time it took to complete the section from 9 months down to 3 months. And the primary reason for this was that the engineers, they did not have to wait upon each other and they could get the work done much faster. But there was one more piece which I will talk about in a minute. And when we did this analysis and we found that with 20 engineers, you could do the projects in 3 months, which means in 9 months to do all the 6 sections, instead of having 6 sections going on at a time, we needed to work only on 2 sections at a time. So obviously that reduced the number of engineers that we needed from 90 down to from 60 down to 40. So this number is wrong here. So the number of engineers reduced from 60 to 40. And the more important piece was that the number of sections as it went down from 6 to 2, which is the work in process if measured in terms of number of sections, went down from 6 to 2. That suddenly meant that these management and support resources could provide much faster response and decisions to the work that was being conducted. And that was another reason for being able to reduce the cycle time from 9 months to 3 months. And so this is the example of focus and finish that is a bit, sometimes you can do an analysis which is very simple without building very detailed project plans and figure out if we put more resources on a phase of a project or a project itself, how much faster can we do the project? And when we put more resources on a project, how much work in process can we afford to have, and a combination of reduced cycle time and reduced WIP will give you a new number for how much throughput you can achieve. So this is how the calculation was done. So now moving on to the project planning exercise. Last time I had talked about that there are different forms of spreading thin versus focus and finish, and there are different techniques or different ways to plan the projects to account for these issues. And first, I will start with project planning. So I will talk about two-tier tasks and show you real examples of how two-tier tasks are used in different situations, different types of projects. Full kitting, a lot of you might already be familiar with. I will just provide a little bit of rationale for full kitting and also show you some examples of full kitting. And the third piece is completion milestones. So this is not an obvious one, but once I explain it to you, it will become very obvious that you need to sometimes insert some artificial completion milestones inside a project. So the use cases for two-tier tasks that I'm going to cover, there are 7 of those. You can just read the screen. I will not read the screen word for word for you because I will pick up each one of these use cases and show you how it is applied. So I'm going to give you about half a minute to read through this. So let's take the example of interactive work. So this is an example from engineering company that makes engineering and manufacturing company that makes large turbines. And the example is from the design process in the turbines. And the turbine, when you are designing a turbine, you have turbines, the compressor, and the casing around the blades that goes in. So whenever you're designing the blade, you have to make some modifications in the turbine, in the compressor, and the casing itself. And once, the people who are specializing in the turbine development versus compressor versus casing, they are different engineers. In theory, you can finish blade 1, the turbine engineer, and then they can move on to blade number 2. Similarly, the compressor guys can finish blade number 1 and move on to blade number 2, and same thing for the casing guys. The challenge though is that even though in theory the turbine and the compressor and the casing, they are parallel activities, there is a frequent exchange of information between the turbine and the compressor and the casing, which means that they should be done concurrently. Not only are they parallel activities from a project network point of view, but from a desired standpoint, we want these activities to be conducted concurrently. And anytime you don't have this good exchange of information between these 3 areas, you either end up with one of the people making wrong assumptions and having to rework because of what was done on the compressor or the casing, or you end up with a lot of waiting time. And the solution is very simple. So instead of the project network looking like this, which will have 6 tasks with complex dependencies in between, and these dependencies will become even more complex if we model all the interaction and the flow of information, and the number of tasks will go up if we start modeling all the information that has to flow back and forth between these 3 disciplines. Instead of that, the project plan should be comprised of these 2 tasks, blade 1, blade 2, and there is a dependency from blade 1 to blade 2. You finish blade 1 and then you start blade 2. And all these 3 different disciplines, they are not tasks but subtasks. And this is the distinction that I'm making. The critical path or the critical chain network is not running through the subtasks. The the critical path in the critical chain network is running at the task level. What will happen as a result is whenever we have to move this task for blade 1, all the subtasks move along with it. Whenever we have to move the task for blade 2, all the subtasks move with it. So this is helpful both in planning when you are trying to do resource leveling and also in execution when you're trying to run buffer management. And on top of that, just from an execution perspective, uh, the practice you want to use is there is going to be, instead of having uh, an engineer for turbine and a team lead for turbine, you will have a team lead who is responsible for an entire blade. And this team lead will decide when this blade design can be started, and they will exercise full kitting and release control at this level. Another example of interactive work is if you are doing um, designing castings. So you have castings, and then you also have clips and mounts and fasteners that are needed for those castings. Normally, when you are trying to design this, the thought process that goes in is that castings are long lead items. So let's get all the castings done first, and then we will do clips and mounts and fasteners later on because they're short lead time activities. But in reality, what you find is that there is interaction between the castings and the clips and mounts and fasteners. So if you design the castings and then you do the clips and mounts and fasteners later, you might have to do some rework on the casting itself. To avoid this, the right way to model this work is not long lead time versus short lead time activities, but pairs of castings and whatever goes with them. So casting 1 needs some clips, casting 2 needs some mounts, casting 3 needs some fasteners. The design for casting and clips should be done together. The design for casting and mounts should be done together. The design for casting and fasteners should be done together. So from a 2-tier perspective, the task would be design group 1, subtask would be casting and clips. The second task would be design group 2, subtask would be casting 2 and mounts, and ditto for the design group 3. So what this will ensure again is that in execution as well as in planning, these related tasks will stay together. And even though you don't need the fasteners and the mounts and the clips until much later, because that is when the orders for those items would be placed, you want to finish them early on, along with the castings. A similar situation, slightly different but similar, is interacting resources. So it's not the design itself that is interacting, but the resources that have to interact. So the example here is that let's say you have different work streams in an engineering project and you have drawings. The drawings get reviewed by someone. Based on the review, there is some rework that needs to happen. Then after you do the rework, there's another review and then there's an approval. All these different resources, the purple, the red, and the blue resources, they are supporting multiple streams of work. So the problem it causes is that if the priorities are not synchronized, then you could be done with drawings, but the reviewer is busy somewhere else. So you could spend a lot of time waiting for the review to be done. And while you are waiting for the review to be done, you move on to some other drawing. And when that review is done, you're not available to do the rework right there. So the rework has to wait. So there's a lot of dead time along a project or along the work stream that you want to avoid. So the right way to model these tasks is not as 15 different tasks, which is traditionally what happens in a lot of cases, especially when you have customers and suppliers involved. The right way to model this task is to say, let's get work stream number 1 done in a compact time. And of course, we know that we need to do some drawings and review and rework and approval. And we will let the plan and buffer management dictate which work stream needs which resources at which time. And so what you begin to see is that with this 2-tier tasks, not only are we ensuring synchronization, better synchronization, but we are also simplifying the project plans. And I want to talk about synchronization a little bit. I repeat from the first webinar that the buffer management, or just having a project network and buffer management, does give you synchronization. But if you try to use buffer management at a very detailed level for synchronization, it actually causes multitasking. It actually causes you to jump between different projects or different paths or different legs of a project all too frequently. So to ensure what we call micro synchronization compared to macro synchronization, to ensure micro synchronization, you need this 2-tier task structure. Very simple, similar effect, but different example is mini assemblies. So imagine that you are building a ship. So you cut some plates, and based on those plates, that you bring those plates together, you fabricate subsections, and you fabricate a section, and you assemble the entire ship. That is a very simple flow for shipbuilding. Now, the problem here is that you could have hundreds to a few thousand plates per ship. And you could end up with a situation where you have many plates done. Let's say there were 100 plates to be done. You're done with 90 of those plates, but none of the sections can be done because each of the section is missing one plate. That is the part you want to avoid. That is the situation you want to avoid through your project plan. And in planning, we can create a very perfect plan to make sure that plate number 1, plate number 2, plate number 3 get done before plate number 4, 5, and 6. But in execution, things will move around. So even with a very good plan that is very well synchronized, in execution, you will end up with a situation where you have lost that synchronization. So the right way to model this project plan is you cut all plates and then you fabricate section 1, or fabricate different sections. Right. So again, you can see that you are getting better synchronization because at a critical path, critical chain level, this is where your network is running. So this entire task will move back and forth, and all the subtasks, which means all the plates under this subtask, this task will also move back and forth together, whether it is in planning for resource leveling purposes or in execution from a buffer management perspective. So this is one thing you are getting. The second is the project network is much simpler. So when we implemented critical chain here, the original project plan was about 3,000 tasks. And we ended up creating a project plan of about 75 tasks out of this. And so we were able to model an entire ship with 75 tasks. We still had 3,000 subtasks, but from a critical path, critical chain perspective, the network got much simplified. Another example is again, you can think of it as a shipyard example, that you need a crane. So you have heavy stuff, pumps, valves, various panels, piping, gears that goes inside a ship. So you need a crane to stage all these heavy items. The actual time the crane takes to pick up something and place it somewhere else is not too long. But the setting up and tearing down of the crane, that itself takes significant effort and time, which means there is a genuine case for trying to optimize the setup time and the set down time for the crane. Now, if I model all these different tasks in the project plan, and even if I account for this setups and try to keep these different tasks together in planning, in execution, they will get spread out. To avoid that, this is what the project plan should look like. We should identify what are the different staging areas for the crane, and the crane can go into one staging area, do all the staging of all the items for that area, then move on to the next one, and then move on to the next one. So the tasks are not that we have to move pumps for area 1, pumps for area 2, pumps for area 3. The tasks are, let's do all the staging for area 1, then let's do all the staging for area 2, and then let's do all the staging for area 3. Another case. So all these cases will sound starting similar, but they are just subtle differences. And that is why I wanted to pick up some real examples. So this is a case where you are building an apartment complex. There are 3 apartments, each with 3 rooms. So you have apartment 1, room A, B, C, apartment 2, room A, B, and C, and so on. Now, the challenge here is that all these 9 rooms, the flooring of these 9 rooms is fairly independent of each other. You can do the flooring in any order. You can pick up room A from apartment 1, then go to room B, apartment 2, and then room A and apartment 3. And the problem though that occurs is that if one apartment is not fully completed, then I cannot do the follow-on work, which might be whether electrical wiring or the building the walls or the framing, the building the walls, or any other outfitting work that needs to be done in the room. That stops if my entire apartment is not done. And if I model the project plan with 9 tasks, then there is no guarantee, either in planning or in execution, that the 3 brown tasks will stay together, and the 3 blue tasks will stay together, and the 3 red tasks will stay together. So the right way to model this project is apartment 1 is 1 task, apartment B is apartment 2 is another task, and apartment 3 is the third task. And different rooms are different tasks. So this is how you should do the flooring. That way you have done the flooring here, and now the rest of the work in apartment 1 can start. You have done the flooring in apartment 2, and then you can start the work in rest of the work in apartment 2. So this is a slightly different case. In this case, we want to enforce an execution sequence. There's a different case where we want to leave the execution sequence flexible. So the ideal sequence for some design, let's say you're designing a building, a factory. So you have some civil design, some mechanical design, some electrical design, and ideally you want to do it in this order, because once the civil design is done, then the mechanical designers know where the machinery or equipment will be placed, and once that is done, the electrical designers will know where, how to design the electrical wiring, etc. But in execution, the actual sequence can change because of resourcing issues, technical issues might come up, or any other factor. So trying to hardwire this sequence at a very detailed level in the project plan can be counterproductive, because you're not going to be able to follow the sequence. Let's say for some reason you have a general idea of the civil design, but the civil design is not done, and you can still do the mechanical design for that room pretty good and not incur any rework issues. Now, either now you have two choices. Either you go and change your project plan, or you, according to the project plan, you are working on the wrong priorities. So the right way to model this task where you want to leave the execution sequence flexible is to put these detailed tasks as subtasks and just have design as a major task. So the distinction between case number 6 and case number 5 is that you want to enforce an execution sequence that is done at the task level. You want to leave the execution sequence flexible that is done at the subtask level. Right, so this is a third advantage of having this two-tier structure, that not only the project plan simpler and you're getting focus and finish, you're giving flexibility in execution to change the order in which work gets done. You're also giving flexibility in terms of resourcing. And very similar concept in terms of giving flexibility in execution is this rolling wave or agile planning, which is you are, especially in the agile world, where you know that you need to do different modules, you have the high level requirements, and at a high level you can pretty much create a good project plan. You can say how much time will it take to design, develop, or test a module, and your estimates at this level are pretty good. But in terms of details of exactly what that design will contain, or what that testing would contain, or what exactly are the different parts of the software you have to touch to do that development, that you cannot predict until you start getting into execution. So being able to have tasks and then populate the subtasks as you go along gives you that flexibility for agile planning. The related point here is, and I think I talked about it last time, was that the Gartner Group, which is an IT advisory firm, and they provide a lot of advice, not just on what is happening with the various technologies and different software, but also on software development practices. So they published a paper recently, and the gist of the paper was that for a long time in Agile, the movement had been to break your modules down into very fine features. They call it epics, which is the big functionality. Epics get broken down into stories, which get broken down into chapters. And or is the other way around. So the estimation process that had been going on in Agile was go down to the lowest level of detail and accumulate your estimates from bottoms up. What Gartner is recommending now is don't do bottoms up estimation. Always do estimation top down. And I think the reason is, one is a practical reason, which is you don't know the details, but you still need to provide an overall plan. Secondly, if you start doing bottoms up estimates, you end up with a very highly inflated cycle time, because at the lowest level, there is so much uncertainty about how long something will take. You really don't know. But when you do an estimate at a higher level, not only do you have a more accurate estimate, but the estimate is also tighter. So this covers the two-tier planning concept. So let's keep moving to the other parts of project planning, full kitting. Right, and the concept of full kitting is very simple. It comes actually from the world of manufacturing, where you want to make sure that before you release a work order into the shop, all the different parts that you need or materials that you need for manufacturing that product or part are available right in the beginning. And in projects, this actually becomes even much more beneficial, because imagine that this is a phase of a project. and you need different inputs at different times in this phase of the project. But if the inputs don't arrive on time, then you end up suffering interruptions. And anytime there is an interruption of this kind, you're not going to keep your resources waiting, you will move them onto something else. So the lack of these inputs will cause you to spread your resources thin, which is again the opposite of focus and finish, obviously. To avoid this, this is a much better situation. Take time, even if you have to start later, take your time to collect all the inputs before starting the project or that phase of the project or a sub project. And your project will go much faster. And not only will the project go faster, you will also realize the benefits of focus and finish in terms of being able to do more projects in the same amount of time. So this is one. The second is when you operate like this, you're also doing focus and finish for gathering inputs. Because now, instead of chasing 300 inputs on 5 different projects, you're going to chase 60 inputs on the first project, then you will chase 60 inputs on the next project, then you will chase 60 inputs on the third project. So you are going to benefit from focus and finish, not only in project execution, but also in gathering the inputs. So I want to just show you the example of full kitting plus completion milestones together. Right? I talked about the third technique being completion milestones. It will become evident from this example why. So this is a situation from an organization, a company that makes communication satellites. So this is all the work that is involved. So you have some customization of engineering, some detailed engineering, some assembly and testing, and then after the assembly and testing, you have some post pre-coupling work, post-coupling work. But the main point here is that instead of working in this manner, you want to work in a focus and finish manner. Because when we are working in a lot of parallel situation, so yes, in theory, we can start some detail engineering before all the customization is done. And we can start some of the preparation for assembly and test before all the detail engineering is done. And similarly, we can start the pre-coupling work before all the preparation is done, and same for the last phase. But ideally, we don't want to do that. That is number one. Number two, when we are operating in this manner, what happens is for the engineers that are involved in customization, now they are spread across multiple projects at the same time. So customization, they were handling 2 projects at a time. Detail engineering, they were working on 3 projects at a time. And the preparation folks, they were working on 2 projects at a time. So you are getting a spreading thin phenomenon when you are operating in this fashion. The ideal way to work is like this. You finish your customization, then you do your detail engineering in a very compact way. Instead of having detail engineering take about 4 months, you want to get it done in about 10 weeks. And each phase needs to be compacted. Now, when you are compacting your project plan in this way, what it means is there's going to be a dead time in the project. So you've finished all your detail engineering, you've placed your orders for all the equipment. Now you don't want to start work on the rest of the project. You want to just hold it. So the full kitting, what it does is it makes sure that you don't start the preparation work. Even though you can start some of the work, you don't start it until all the items that are available, required for that phase, are available. So this allows you to enforce this hold period. And then once all the materials are there, all the equipment is there, you can finish this as preparation for assembly and test in a focus and finish manner. The other side is you want to enforce detail engineering to be finished by a certain point. So this is where the completion milestone comes in. So contractually or from a lead time perspective, we are not required to finish detail engineering by this point in time, which is 30 weeks after the start of the project. But we are going to force this completion by inserting a completion milestone in the project. So this combination of full kit and completion milestones is very beneficial from a focus and finish perspective in very large projects. So I have some exercises for focus and finish project planning. And I'll just show you what kind of exercises there are. Right, so if you are interested in those exercises, I can email them to you, and then I will also email you the answers. But to give you a preview, so there is some exercises about there's a problem that is given to you, and then you have to figure out what is the best way to plan this project. Then there is another problem which is on how to organize this project plan into a two-tier project plan. There's a third exercise of a similar nature. So if you are interested in receiving those exercises, you can email me and I will send you the exercises. And the solutions are contained in this PowerPoint, which will be available to you after the webinar. With this, I'm finishing the section on project planning, and I'm moving on to pipeline planning. So pipeline planning, I think the concept is pretty straightforward. Everyone knows about it. You need to identify your constraints and stagger your projects based on the constraints. So let's say you have 3 different projects going on, and the red resource is the most overloaded resource. So that is the resource on which you want to stagger your projects. But when you stagger the projects, and this is where the focus and finish idea comes in, is you should stagger the entire projects, not individual tasks. And the point here is that as we account for the finite capacity of this red resource, and we look at all the tasks in the projects that need this red resource, we should not schedule our projects in a way that will cause these tasks to spread out. We want to retain the tasks together within a project. We don't want a situation where you're working, your red resources working a little bit on project 1, then a little bit on project 2, then a little bit on project 3, if in reality they could actually have performed all their tasks contiguously within project 1. So as much as possible, you want these tasks to stay together. So you want to stagger projects, not schedule individual tasks. So this is one aspect of focus and finish that should be retained when we do that should be implemented when we do pipelining. The second challenge in pipelining is that when we do the scheduling of a pipeline, so imagine that you have scheduled this pipeline and then you get into execution, and there are some delays on the golden task. There's some delay on the blue task. Now, as these natural changes and delays happen, you should not see an impact on your overall project start and completion dates. And so that is the second thing you want to ensure. And the third piece is that these resources, sometimes the resources are not just the resources that are working on the tasks, but also the management and support resources that are supporting these tasks. So we also need a mechanism to account for management capacity. Let me explain these points a little bit in more detail. So here is the situation. The legend here is that this yellow represents the type of resource I need for a task, and the border represents what project it is. So I have 2 projects. Both the projects have some yellow resource requirements and some blue resource requirements. And this is my number of resources, both for yellow and blue. Now, if I try to schedule task by task, I end up with a Tetris problem. I will not have a situation where I can find a perfect fit for this yellow task within the first project. So this is a yellow task from second project. These are the yellow tasks from the first project. So either I'm going to put this task in and be left with a capacity gap, or I might not have enough gap here. And when I force this task in, it increases the cycle time for the first project. So the exact fitting is impossible if we resort to task by task scheduling. Therefore, timelines stretch and you still are left with capacity gaps. So all the perils of your spreading thin, uh, you start embedding those right into your plans if you schedule task by task. On top of that, execution we know will be different anyway. Now we can spend a lot of time creating exact schedules for every task, but in execution, some tasks will take longer, some will get done faster. So there is no point in all this scheduling anyway. Worse, this is the worst situation. So whatever plans you come up with, and in the plans, if you ended up stretching your timelines or leaving capacity gaps, they will get only worse in execution because delays, they cascade downstream. So anytime there's a delay on a blue task, now the follow-on yellow task will get delayed, which means the other yellow tasks that were downstream of that yellow task will also get delayed. So your stretch will keep increasing and the capacity gaps will keep increasing. So therefore, the right way to do the pipelining is to, yes, we should pay attention to where the constraints are. But then we need to, instead of going directly into task by task scheduling, we should identify the phases that consume the constraining resources the most. And then we need to stagger on those phases. Right? So this is what I mean. So you have a project where there's 3 phases. And yes, we need these red resources in phase 1 and red resources in phase 3. But most of the requirement for the red resources is coming from phase 2. So very typical if you are doing aircraft maintenance and repair. So yes, you need some mechanics when you are disassembling the aircraft, but most of the work in the disassembly phase, which is the blue phase in that case, is going to be done by inspectors. Then when you get into repair, that is when you need most of the mechanics. And by the way, when you are doing the repair phase, you need not only the mechanics, but you might also need inspectors or engineers. So you also need other resources. But all we are saying is, based on my constrained resources, let's identify which phases of the project consume those resources the most, and then stagger those phases. So instead of scheduling each individual task, what we are doing is scheduling the phases. This ensures that your pipeline will not be overloaded, of course, but more importantly, all the red tasks in a phase, they will stay together. So you will end up getting focus and finish both in planning and in execution. Importance of modeling management capacity, right? So this load and capacity picture is just looking at my resources that are defined in the project plan. But in reality, as we had discussed the last time, that project work does not flow from left to right. Whenever you are working on a task and you get stuck, or you need a decision or help, you need to go to management and expert resources, get those problems solved, and then you can move on. Now, and if you don't have, if you are overloading your these management resources, the impact on cycle times is much worse than the overloading the direct resources, because the variability in responding to these problems is very high. Right? We covered this in this the last time, so I will not repeat the entire logic. And the simplest solution here is combine this idea of phase-based staggering, but one more injection that is needed is, instead of just looking at resources and the effort that is needed, you can come up with limits, WIP limits, by phase based on management capacity. So for example, you can say that in the systems integration and testing phase at any given time, you can handle only 2 projects, but because you need a lot of management coordination in that phase. And you can get more sophisticated to say we can handle 3 small projects and 2 large projects, or whatever combination you want to specify. But the best way to model management capacity is to specify WIP limits by phases, and then use that WIP limit to stagger your projects. Okay, so we're going to talk about resource planning, and I think one main concept here is flexibility. So that is what I want to illustrate. And I have not tried this using a webinar before, but I'm going to try it this time and see if it works. So we're going to actually run a simulation and see what happens. So the setup is this. I have 5 projects that need to be done. Project number 1, project number 2, project number 3, 4, and 5. And these are simple projects. There's a red task and there's a blue task in each of these projects. So not complicated, very simple. And red task needs red resources and the blue task needs blue resources. The total number of red resources I have is 21. The total number of blue resources I have is also 21. And the actual number of resources you will need to perform a task depends on the roll of a dice. So if the dice comes up as 5 for project number 1 for red resource, you will need 5 red resources to perform that task. Right? So this is the setup, that I need resources. I need 2 different types of resources, and the actual amount of resources I need, there is a variability there. Sometimes I can make do with 1 resource. Sometimes I might need 6 resources. And the first simulation we're going to run is when resources are pre-assigned. So what we mean by that is each project manager will get 9 resources. So they can choose 6 red, 3 blue, 5 red, 4 blue, 3 red, 6 blue, 4 red, 5 blue, whatever combination they want, they can select. And then they will roll the dice to find out the actual resource requirements as we discussed. And if the dice comes out to be a higher number than resources have, their project will be released. And then we're going to measure the project managers on this on-time delivery. The second simulation we will run, we will still roll the dice, but we will not pre-assign the resources. We will assign the resources after the dice roll. And if then, based on that, if you get resources, if you have enough resources in the pool, then you will get the resources. If you run out of resources in the pool, you will not get the resources. And then again, you will get measured on on-time delivery. So I'm going to run this simulation using a spreadsheet, and I can mail this spreadsheet to you also. So I'm just going to pick up some random numbers here. So the random numbers are the first project manager. They say that, I need 9 resources. Let me give 3 red, 6 blue. The second one says, you know what? I need 4 red, 5 blue. The third resource manager says, let me go 6 and 3. And the fourth one says, let me go 5 and 4. Now, remember, we had 21 red resources and 21 blue resources, which means the fifth project manager is left with only only 3 and 3. Right? So this is the reality. And now I will roll the dice and see what happens. So the way the simulation is happening is each of these boxes represents a roll of a dice. So this is simulation number 1, where project manager number 1, they get 1 and 5. So they need 1 red resource, 5 blue resources in this case. They need 3 red resources, 2 blue resources, the second project manager. And if I run this simulation, now let's look at the results. So in case where my resources have been pre-assigned or pre-allocated, this is what my simulation threw up. And what it says is I need 2 red resources, but I was given 3, which means my red task will be on time. And I had 6 blue resources, but I needed only 3, so which means my project is on time. So in this case, this project number 1 on simulation 1 is on time. Project number 2 is also on time because I need 4 and 4, but I had 4 and 5. Project number 3 is late because I need 5 blue, but I have only 3. Project number 4 is on time. Project number 5 is not on time. So I got 2 late projects and 3 on-time projects. Going down here, following the same logic, project number 1 is late. Project number 2 is on time. Project number 3 is on time. Project number 4 is late. Project number 5 is on time. So I have so far 4 late projects and 6 on-time projects. Let's keep going. So 7th project is on time. 8th project is not on time. 9th project is on time. Sorry, 8th project, yeah. 10th this is not on time. So I have so far 9 projects on time. 8 projects on time in the first 3 simulations. If I go to the 4th simulation, so if I quickly look at the results, I have 2 late projects. So I have so far 11 projects on time. And in the 5th simulation, late, late, on time, on time, on time. So I have 14 projects on time if I pre-assign my resources. But if I do not pre-assign the resources, which is the scenario here, that we will still use the same dice roll, but we will assign the resources after the dice rolls and see if our project can be on time as a result. So in this case, the first project, they will get all the resources they need. Second project will get all the resources. So 2 plus 4, 6 plus 3, 9 plus 4, 13 plus 4, 17. I need a total of 17 resources, red resources, and I have 21 red resources. So all my projects will be on time and I will be left with some resources still. 3 plus 4, 7, 12, 13, 14. So if I do the calculation this way, what I will find is so all my projects can be on time. So in one case, I had 17 projects on time. In the other case, I end up with 25 projects on time. Right? So this is the advantage of resource flexibility. And the question now is, how do we provide this flexibility through our resource planning and execution techniques? And what we recommend is that at the time of planning, first of all, don't assign specific resources or allocate resources in planning. So when you do pipelining, when you do this pipelining, you're not allocating resources to a project. All you are saying is when a project starts and when a project ends. So you're not allocated any resources to the project. And then on top of that, you deal with generic resources instead of special named resources, and I will explain that in the next slide. And sometimes you have a situation in projects where resources are not very flexible, in the sense that resources are not like machines where you can easily move them between projects. So a lot of times what we find is you might end up allocating 40, 50, 60% of the resources to a project, and the rest of the resources you will keep them in a shared pool. Right? So this is environment specific in terms of how many people get dedicated versus how many people get shared in execution. But the concept that I wanted to illustrate to retain this flexibility is the concept of logical resource hierarchy. So the situation here is I have a development group. These are back-end developers. So for in software development, you have back-end developers, front-end developers. So I have back-end developers, 5 of them. Out of those 5 people, Tom and Ashok and Chen, they can deal with stack A. Stack means the different types of programming languages that you can program in. And Tom and Ashok and Monica and Bob can do programming in stack B. So what you will see is that Tom is multi-skilled, Ashok is multi-skilled, Chen can work only on stack A, and Monica and Bob can work only on stack B. So the point here is that I don't want to assign Tom or Ashok or Monica or Bob at the time of planning, pre-assign them to a specific project, because then I'm going to hard allocate them and lose the flexibility in execution. I want to do assignment at a skills level, which is stack A versus stack B. And if possible, I want to even do assignment at a higher level, because sometimes when I'm looking at a pipeline that is maybe 6 months, 12 months long, I don't know whether I will need these people, this a specific project will need stack A or stack B. So I assign them at a higher level, which is backend developers. And what the trick here is to say that I have 3 people. So my capacity for stack A is 3. Capacity for stack B is 4, but the combined capacity is not 3 plus 4, 7, it is 5. So this is what I mean by logical resource hierarchy. It's not a simple addition of 3 plus 4 is equal to 7. This is saying that if I assign my backend resources at this level, then I have 5 units of capacity. If I assign my resources at this level for stack A, I have 3 units of capacity and 4 units of capacity over here. So these are the numbers that will go into your resource and load capacity calculations. The next idea is reserved capacity. Right, so we know that in projects you need some protective capacity, but in addition to that, you also have non-project work that comes along, and for every organization it is different. So we have had situations where non-project work can be as high as 60 to 70% of the total work, and as low as 20 to 25%. Actually, as low as 5%. So you have some non-project work. You also need protective capacity to account for uncertainties. Plus, at the time of planning, you don't have visibility into all the projects that will come along. Your order book, for example, if you are supplying equipment, is not full. So you don't know what projects will come in. So the idea there is that you want to leave this reserve capacity for all these 3 different categories: for basic uncertainties and how much time and resources it takes to do a task; for non-project work, which you cannot forecast but you know will happen; for drop-in projects, you know drop-in projects will happen, but you don't know which ones and when. So you want to leave aside this reserve capacity when you are doing your pipelining. The beauty of this reserve capacity is that you can relieve this capacity if you don't use it. So, for example, let's say that I reserved a slot for a drop-in project, and the slot is in the month of June. We are sitting in April now. Come middle of May, we feel that we're not going to get that project. so we can release that capacity and use it for the actual project. So we don't lose this reserve capacity if we don't use it. We end up actually using it, but it is there if we need it. Okay, so I think we are going to finish this webinar a little bit faster than we had planned. We are on to the last part of this focus and finish techniques, which is fast issue resolution and buffer recovery. Right, so these are important from a focus and finish perspective. I'll explain very quickly how. As we talked about this, right? The projects don't move from left to right. Whenever there's a problem, the work goes up to a manager or an expert and who resolve problems or make decisions, and then work can move on. Now, if managers and experts don't resolve issues in a fast manner, so it's not just a question that they have capacity, but if that capacity is not available instantaneously, then you will lose time on the project and you will move away from focus and finish if it's going to take a long time for an issue to get resolved. So in addition to planning, which means not overloading management during the planning, you also need additional techniques in execution to ensure focus and finish. So one example is workshop mode. And I'll explain this using an example. Let's say that you are working on engineering drawings and you have multiple reviews that need to be done by the customer or reviews to be done by an expert. Now, instead of having a cycle of where you produce a design, it goes to an expert through an email or through some collaboration software, they look at it, they throw it back to you, then you do the rework, and then it goes back for review again. A better technique might be for the person who did the design and the person who's going to do the review to come together in a workshop mode. All the questions get answered right there, and even the rework can happen in that workshop itself. And that way you can, something that would have taken you 20 days to finish, you can finish it in a day or two. So it looks like is a wastage of capacity by having the expert be sitting in the workshop while the engineer is modifying the drawings. In reality, it is much better from both a project cycle time perspective and a throughput perspective for everyone to come together, get the work done, and then move out. So this is one way to ensure instantaneous availability of experts in management. Second technique is also very simple, which is a help desk. So let's say the issues are coming up every day. And now, instead of having to send an email and saying, hey, Tom, when are you available? And then Tom saying, Sanjeev, I'm really swamped. Can we meet 3 days from now? Meanwhile, you're sitting there twiddling your thumbs. Instead of that, the recommendation for Tom is to have pre-scheduled help desk times every day, whatever the time is. That way, everyone in the organization knows that then if they need Tom's help, they can walk up to Tom during those help desk times and get the issue resolved and keep moving on. And so that is the idea behind the help desk. So whether it's Tom is an expert or Tom is a manager, it's a great idea to help this help desk. In fact, one of the situations we want to create when we are doing an implementation is a manager's calendar in a project organization should never be full. There should always be empty slots on a manager's calendar in a project organization, because if the manager is not available, and everything stops. And a third idea, which is similar and related but slightly different, is if you have many reviews that are getting done. So a lot of times in projects, what will happen is a specific review, where there is, sometimes they call it review cycle 1, which is PDR, CDR, there are different names. So specific reviews by specific project get scheduled far out in the calendar. So you start a project and you say, you know what, we're going to have a a preliminary design review for this project 3 months from now on Monday. That is ridiculous, right? Because you might not be ready for that review. So instead of that, you can still fix calendar in terms of, hey, Sanjeev needs to be available for reviews, once a week or twice a month. Exactly which reviews will happen, that will get determined based on what is happening in execution and based on what is happening in buffer management. On buffer recovery, there is not, there are lots of techniques for buffer recovery, but from a focus and finish perspective, the main idea is a tendency that we have seen in projects is that the moment your buffer is running red, you start doing things in parallel. You start breaking dependencies, and you start doing more and more legs of a project, or more and more sub projects, or even more and more projects in parallel as your buffer start turning red. Our experience 100% of the time is that the more you do in parallel, the worse the buffers get. And that is kind of a vicious cycle that ends with the entire implementation of focus and finish collapsing. What we strongly recommend is find opportunities to not parallelize but serialize even more. So if you're finding that you have a project that has got 3 streams that are running red, then put one of those streams on hold, tackle the 2 red streams, and then move your resources and management capacity and expediting capacity to the 3rd stream. Similarly, if you have a portfolio of projects and 20 projects are running, and you find yourself in a situation where 12 of them are red and they are the risk of being late. So the best idea would be to, out of those 12 red projects, if management capacity is the constraint, issue resolution capacity is the constraint, stop working on 3 or 4 of those projects, finish, get the first 6 or 7 projects out of red into the green, and then move to the other projects. So the idea is, instead of parallelization, serialization, and which is absolutely the opposite of what happens in traditional project management and whatever instinct is. Okay. Any questions on this part?
I have one question in here from Gabriel. Is there a need to resolve conflicts between phases and resource allocation?
Okay. Can we open up the mic to Guy? I want to understand the
Yes.
question.
Yes.
Okay, can you hear me?
Yes.
So Concerto, the realization software, has a resource functionality which actually predicts the load on resources. The idea of focus and finish actually at the first task level and actually has allocation of resources on a broad sense, which really does not represent the real usage. So does this really mean that, or might not represent, especially if you're talking about those resources who are not the main ones who participate in this task? The question is, should you have actually abandoned the idea of getting some forehead problems with tasks, resources being available because of focus and finish, or is there a better way of inserting the estimates as to the resources required at each task level at the first tier?
Very good. So let me make sure I have understood the question. And guys, there is an echo here. You might want to put yourself on mute. So the right. So the question, I think, is twofold. And Guy, you can correct me if I'm wrong. One is that just having load to capacity at the task level and an overall level is not sufficient, because if you want to stagger by phases, you need additional information. And the second way to construe that question, at least I am construing it that way, is that should I even need task level estimates to come up with load to capacity? Should I not have phase level estimates? Guy, is that fair that I have understood your question right?
It's a good way of trying to tackle it. Either way you do it will actually give the answer to this question of trying to be accurate on resource estimates vis-a-vis implementing focus and finish.
Very good. So this is what I would recommend, that if you have project plans built, which means you have done some effort, put some effort into estimating tasks and resources, then you don't need to just stop at load to capacity overall. You also need to find out what it means for different phases and where are the constraining resources being used in which phases. So whether it is done through software or you do it manually, regardless, you need to take that information about load to capacity to the next level to say, this constraining resource, in which phases is it being consumed the most? And then be able to stagger based on those phases. If you have not built project plans, which is normally the case when you are doing slightly longer term planning or just annual planning, then you can have templates, and these templates can be either at the phase level. And what we find though is when you are following a 2-tier task structure, you can have those templates at a tier 1 task level also. So you can do that estimation of resources either at a phase level, because all you are interested in is pipelining. You're not interested in other details of the project plan. Or you can do that estimation at a tier 1 level without having to go down to tier 2.
So I guess this resolves the issue of the pipelining based on the phase level, because there you're really not interested at the level of resources, but more of pipelining the phases. But on the other hand, the question is there still a possibility that there will be a new bottleneck appearing on one of your resources due to the combination you are tackling right now on your projects, and because of the inaccuracy that comes with the 2-tier concept, you may not be able to see it, or maybe you will see it only as you have an issue of task waiting too long in front of certain resource types.
Okay, so that is good. So I think great question, but I probably the answer, right? That in your mind, which one is going to be more accurate, tier 1 or tier 2?
So clearly, if you talk about the estimates, the tier 1 should be more accurate, because all the good things you said about top down and the fact that you're looking at something of more experience rather than aggregating all the tasks bottom up. But I'm still trying to get some visibility on the issue of how to avoid potential new bottlenecks because of the general numbers that are going with the tier 1 as compared to the actual life.
That's great, right? So 2 responses to that, Guy. So first, I want to just bolster the benefit of tier 1. The tier 1 will be more accurate than tier 2, and tier 1 will also be more accurate than the phase level resources, right? Because at a phase level, you are at too high a level and it's going to be too approximate. At tier 2 level, you're trying to be more accurate than the noise. So tier 1 is the right place to estimate your resources even for pipelining purposes. But moving on from there, yes, in reality, you might find that tier 2 work can be more or less than what you estimated during the pipelining process. But that is where the idea of resource flexibility and reserve capacity comes in. Right? Some tier 1 tasks will consume more capacity of a red resource. Some tier 1 tasks will consume less capacity of a red resource. Some projects will consume less, some projects will consume more. So the more flexibility you have in your resources, the better off you will be. And the second is, that is what the reserve capacity will also help you handle. Is that okay, Guy? Okay. Guy, I'm assuming I have answered your question.
Yep.
Okay. Right. As I'm answering this question, I think the additional clarification I want to give is that your drum resource can change over time. Actually, it will change over time. And does not mean that every time you sit down and do your pipeline planning, your drum is different. No, it cannot be different from 1 week to the next, to the next, to the next. But over time, it can change. So which resources / which phases you are staggering your projects on can change over time. Right? So I want to exemplify the phase aspect. So sometimes you have projects that require all the 5 phases that are typical in your organization. Sometimes you have projects which are more of modification projects that don't require all the 5 phases, they require only the last 2 phases. So depending on your project mix, which phase is the drum or which phase is being used to stagger, that can change. And of course, which resources are the constraints on which you are trying to determine the stagger, that will also change. Okay. Any other questions on this focus and finish techniques?
I see no new questions at this time.
Okay. So the last part of this presentation or webinar is, I don't have a slide for that, I'm sorry for that, but it's very simple, which is the implementation part. So exactly what binds are required, right? So I think in TOC there is a tendency, TOC circles, to make this buy-in thing a big deal, and cultural change and buy-in, and things are much simpler. Things are much simpler. I think part of the buying challenge is self-created, which is when we start talking about behaviors, you need to stop multitasking, or you need to be a roadrunner. We are almost accusing people, not recognizing that they are victims of the system they are operating in. At a system level, the fundamental buy-in that is needed is, do you need to improve project performance? If you don't, then there's no need to change. Or if you need to improve your performance by 5%, 6%, you can do anything in projects and situation will improve. But if you want dramatic improvements, which means if you want to cut down your cycle times by 30, 40, 50, 60, 70%, if you want to increase the rate of your project completions by 20%, 30%, 40%, then you need to move from the local optimization mode to a global optimization mode. That is first buy-in. The second buy-in is, the meaning of global optimization in projects is focus and finish. And those are the two fundamental buy-ins that you need to implement focus and finish. Now, if you need critical chain on top of it, which is if you have large projects, or if you have a large organization, when I say large, if you have about 20 people or so, or even 40 people, 30, 40 people, you can operate without critical change project management. You can implement the ideas of focus and finish using some visual boards, some project plans on the wall, some Kanban system. But if you are getting to more than that, or if your number of projects is increasing, or the size of the projects is increasing, then you start needing project plans that are live project plans in execution. That is where critical chain comes in. So for the critical chain, the only buy-in you need is this that this fixed date schedule don't work. We need flexibility in the schedules. And if we operate to fixed date schedules, this is what we will end up with. Right? So the buy-ins are not about individual behaviors. The buy-ins are not about cultural change. The buy-ins are about, do we need improvements? If we need improvements, focus and finish will give us those improvements. And if we need a formal project management system, then we need critical change project management to be driving the project management system. And so this is on the idea of buy-in. The why and when you need software, that is also a very summary answer, that you need software for both focus and finish and CCPM. Right? So if you're going to use CCPM, you need software. If you can just do it with something on the wall, without critical change project management, without buffer management, then you don't need software. But if you need critical change, you need software. And for focus and finish, for large projects, if you need to implement ideas like full kitting, two-tier planning, pipelining, etc., if you have a larger environment, then you need software for it. And so bottom line is, CCPM is important. If you want to use project plans, then you need critical change project management. And the two don't need to be together. You can implement focus and finish without critical change project management. And so with that, I'm at the end of my webinar. There's a question from Lars. Does focus and finish not require an organizational change on several levels? So Lars, at the bottommost level, those people are responding to whatever is being thrown at them. Engineers will work on what is given to them. If you give them 20 things to do, they will work on 20 things. If you ask them to move between 5 projects at a time, they will move between 5 projects at a time. If you ask them to work totally in silos instead of working in a collaborative manner wherever there is frequent exchange of information, they will do that. Right? But their tendency will always be to do the right things. Because if I'm a mechanical engineer and I need to collaborate with an electrical engineer to get my work done, even though I'm responsible only for my work, I will make sure that collaboration happens one way or the other. But it's going to be very difficult for me if my plans have not been structured in a focus and finish manner. So the focus and finish buy-in really is at the top level. That is the top level of management that needs to just see the difference between operating in a spread thin, keep everyone busy mode versus focus and finish mode. And it's not a difficult buy-in. It's actually very simple. I think the challenge in critical change has been that we have not articulated what that buy-in is, and then we kind of talk about that top management doesn't understand, top management is stupid, top management is, whatever it is. If we cannot articulate our logic of why our solution is better, no one will buy into it. Just because Ellie Goldratt wrote a book that a few, 0.5% of the people like, does not get the buy-in. Buy-in comes from simple logic. And I think focus and finish is a very simple logic.
Yeah, I agree. The whole concept you have presented over the last two webcasts are very compelling argument. My question is, when I get back to work as a project manager, for example, it requires that the project management office that handles the pipeline of projects, that they have this understanding. It requires that the line managers that provides resources to my projects or all other projects also have the same understanding. So that's why I'm asking about a higher level. You need to actually rethink how to do projects.
That is fair. I think that part is fair, right? That if we are talking beyond buy-in into changing some processes, right? So the understanding of focus and finish needs to be there at the management level. That PMO office, from a governance perspective, so that they can follow the right metrics, resource managers or line managers, so that they can think of their resources in this manner, right? And then there are changes that are affecting all levels of the organization, mechanical changes, where there is the changes in project plans, changes in the pipeline, changes in some of the way the meetings are set up. So absolutely, those mechanical changes are going to be there at multiple levels in the organization.
Thank you.
Right? The buy-in part is what I'm contesting, that we make a big deal out of buy-in. Right? I think if we provide a better system not as in software, but a system as in system of management, or the system under which we are operating, things will automatically change. My favorite example is, I've used it many times, so it might be a repeat for many people, is I totally disagree with Ellie Goldratt that you need to change before you can use a new technology. I think new technology can force change. When I bought my iPhone, I did not have to agree to change my work habits or my reading habits or other habits before I bought the iPhone. iPhone has changed my life. I did not need to change my life before using the iPhone. And I think TOC is the same way, or it can be made the same way. That if you implement a proper system, it will change things. Any other questions?
None at this time.
Okay. So again, if you are interested in doing some exercises, those 3 project planning exercises, let me know, and I'll be glad to share them with you. Thank you. This has been a good experience for me also, in terms of consolidating my thoughts. And sorry, Milan, that there is no other literature out there on focus and finish, but hopefully this webinar was a step forward.
There's a request for you to get that book written as quickly as possible.
Who reads books nowadays?
That would be Lars. Guy Brill, hold on. He wants me to put him on. So just a second. I got to get back to here. Hold on 1 second. Here we go. Go ahead, Guy.
So Sanjeev, it's just following on last question about the buy-in. You made a pretty strong point about top management being the focal point for the buy-in of focus and finish. But I think if any one of us hearing this presentation has in mind of going to some organization and do this kind of buy-in, I guess there needs to be the right prep work when presenting the changes required at the different, be it the line managers or the PMs or the PM office, that's the pipelining, etc., because many of the problems or resistance to critical chain comes from those involved people who somehow feel that their way of doing business until now is going to change, and they're not sure that this is going to be good for them or that they understand the logic. So there's one thing of getting such a project to start and work, but there's another thing of buying in all the stakeholders in the organization, that each and one of them needs to have his piece or view of why he should go and do it this way. And I guess part of such a presentation of yours might be somehow the specific points that are addressed to each and one of those stakeholders.
Okay, so yes, guys. So I would say two things, right? One is that the buy-in needs to be narrower in terms of how many buy-ins do we need. And the second is buy-in needs to be narrower in terms of who needs to buy in. And this is what I mean by the second statement. If your measurements at the top change, if at the top you convince them of focus and finish, and you change measurements from utilization to speed, fundamentally in all of TOC implementations, that is the change. You need to find measurements that are for speed rather than utilization. I mean, operational level. At a cost accounting level, there are throughput oriented versus cost allocation oriented, right? If you change those measurements, things will change below. If you change the measurements, provide people the mechanics. So one favorite example I have is Stephen Covey. He was at a keynote speaker at one of our project flow conferences of realization. So he had this example of Copa Airline. Copa Airline used to be the worst performing airline, and I think now they are one of the best performing airlines in South America. Their on-time delivery was horrible, profitability was horrible, everything was bad. And the convincing that Dr. Covey did with the top management was, hey, if our flights start taking off on time, everything else will improve. And as soon as the top management agreed with that logic, they said, okay, our goal is to have every aircraft take off on time, and you guys on the front line figure out what we need to do to get this aircraft take off on time. So the frontline changes happened, according to Covey, in a period of about 4 months. The flight attendants were helping people shut the gates. Like, so everyone was working in a collaborative manner just so that the aircraft could take off on time. I think the people at the bottom levels and the middle levels, they are not resistant. They are looking for leadership. So anyway, that is my perspective. I know it could be very different from most of the people in TOC, but that is my perspective.